So for number one, we're going to graph and label the points. We have A at 1, 1. We have B at 1, 5. 1, 2, 3, 4, 5. C is at 5, 1. 1, 2, 3, 4, 5, 1. C. Now, for part A, it says give the ratio for tangent B. Well, in class, before school closed, we talked about how the ratio of sine is going to be the opposite side over the hypotenuse side. Cosine is adjacent over hypotenuse, and tangent is the opposite over the adjacent. Now, you can only use sine, cosine, and tangent with right triangles up to this point. So for the ratio of tangent B, we're looking for the opposite over the adjacent because we're talking about tangent. So if we look at the triangle that we have right now, we have AC would be considered the opposite side because it's on the opposite side of the triangle. So the opposite side would be 4, and then the adjacent side would be the side that's next to angle B, which would be this side. So the adjacent side is the leg that is next to the angle, so which is a length of 4 as well. So then the ratio would reduce to 1. 4 divided by 4 is 1. What is the measure of angle B? So right now we want to find the measure of angle B, and a lot of times when we find the measure of angle B in our paperwork, you'll see it look like theta, which is this symbol right here. So what I can do is set up an equation and say, okay, the measure of angle B. So we have the opposite and the adjacent, which makes us use tangent. So we have tangent of theta should equal the opposite over the adjacent. And so if we want to find the angle measure, what we would do in our calculators is use the inverse of tangent to do so. So we can say the inverse of tangent, 4 divided by 4, should equal your theta value. And that's how we can find theta. So let's go over to Desmos. And we're going to do, first you want to check your little wrench and make sure that you're in degree mode. And then we're going to click on functions to get our tangent. And then we're going to say 4 divided by 4, or you could just say 1. And that, oh, you know what I forgot to do? I forgot to make it the inverse of tangent. So notice that that is a different value, and that is not going to work for our angle measure. So I'm going to X that out. When we pick our functions, we want to pick the inverse of tangent, the one with the -1. So now we have 4 divided by 4, which is 45 degrees. So our angle measure for theta is 45 degrees. And then we can go ahead and write that on the line. And what is the slope of BC? Well, slope is rise over run. And if we take a look at the triangle, we have to rise 4 spaces and we have to run 4 spaces as well. But because we're going to the left, we're going to make it a -4. So our rise was a +4 because we were going up. But then our run was a -4 because we were going to the left. And so a positive and a negative would reduce to a -1. So the slope of the line BC would be -1. I am going to erase the pink because it's overlapping with my last problem a little bit. So if you need to see it again, though, you can go ahead and rewind the video. For the next problem, we want to find X and Y to find the area of the triangle below. What helps me with these problems is to write down what I'm trying to find. So I need to know the area. So when I'm done, I should be able to answer the area of a triangle is half your base times your height. And sometimes when I write down this formula, it tells me what I need to find. I need to find the base, which is your X value, and then I need to find your height, which is your Y value. I like to find them alphabetically, so I'm going to find the X value first. So if this is the angle measure that we're given, the X value would be our adjacent side because it's the leg next to the angle, and the 12 would be our hypotenuse. And I like to use the 12 because it's going to have given information, so you don't have too many unknowns. We talked about the trig function, SOHCAHTOA. Sine is the ratio of the opposite over the hypotenuse. Cosine, the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So if we're trying to find the adjacent and we have the hypotenuse, then that means we're going to want to use cosine right now. So we can say that the cosine of our angle measure is equal to the adjacent side, x, we don't know, and the hypotenuse side, which is a length of 12. So now to get the x by itself, to find out what x is equal to, we're going to want to multiply by 12 to get the x by itself. And whatever you do to one side, you must do to the other side. So now when the 12s divide to 1, we're just left with x on the right. And then in our calculators, we're going to want to do 12 times cosine 46. So if we go into decimals, we can then do our 12 times cosine 46 times cosine 46. And so we'll get about 8.33. Let's go ahead and round it to the nearest 10, so 8.3. So x is 8.3. I like to write it in the picture too, 8.3. So now we want to find y. I'm going to go ahead and switch colors up right here. So y is opposite from the angle measure. And it's always good to go back and use the knowns, which is your hypotenuse. So we're going to go ahead and use the hypotenuse and the opposite. So now when you're using the hypotenuse and the opposite, you want to look to see which trig function uses the opposite and the hypotenuse, and this time it's going to be your sine value. So let's go ahead and set up an equation using sine. The sine of your angle measure, 46, is equal to your opposite, y, unknown, over your hypotenuse, which is the 12. So now to get the y by itself, what you can do is multiply 12 on both sides. That gets y by itself. 12 divided by 12 is 1, and 1y would be y. And then we're going to multiply 12 times sine 46 in our calculator. So 12 times sine 46. Oh, I wrote that in the same one. I did not mean to do that. 12 times sine of 46. So that would give us 8.6. We'll round to the nearest tenth. So now I'll have 8.6 is my y value. So now when we want to find the area, we'll plug in all of the unknowns. So now we have the area of a triangle is half your base. Well, now that we know the base is 8.3, and then we know that the height is your y value, which is 8.6. And so now we can go ahead and calculate our area. I'll go ahead and do that in decimals so you can watch. So half, 8.3, 8.6. So clear that out. 0.5 is easier to write in than a half, but it's the same value. So I'll say 0.5 times 8.3 times 8.6. So we have 35.69. 35.69. Do they give us a unit? No, so we can just say units squared. And then that would be our final answer because we found the area. All right, moving on to number 3, what is the value of x in the diagram? So I did add I added a hint here in the review, but there's not a hint on the team test. So please make sure that you come back and look at this as an example before you do that one. So it does tell us to draw the height line inside the triangle. So if I draw the height line inside of the triangle, it's going to look like this. Now the height line is always going to make a right angle with that opposite side. So now when we do this, we see that this orange triangle is now a 60, 90. This angle would have to be 30 degrees in order to add up to 180. Now, a 30, 60, 90 triangle is a special triangle because they always have the same ratios for all of the lengths of the sides. So the ratio of a 30, 60, 90 triangle, 30, 60, 90. The ratio of that triangle is going to be that the side opposite, you know what, I'm going to draw it the same way as it's drawn in that figure to help out. So the side opposite from the smallest angle is your shortest side. So we'll say that that's x. The hypotenuse is always twice as big in a 30, 60, 90 triangle. The hypotenuse is always 2 times bigger than the smallest side. And then the side across from the 60 degree, to get that value, all you need to do is multiply the smallest side by the square root of 3. So x times the square root of 3. And if you want to replace them with ones, you can, because let's say if x were 1, then 2 times 1 would be 2, and then x would be 1 as well here. 1 square root 3. So we can replace that with ones to make the calculations a little bit easier in our proportion. So if we wanted to figure out this length right here, let's just call this x, and then we'll call this y, and we'll call this z. So if we want to know the x value, we would set up a proportion. And so that proportion would say, okay, x corresponds with the 1 in the triangle below. And then we know that we've got a 6 in the triangle up top, and the 6 would correspond with the 2 below. So if we were to cross multiply, 2x is equal to 6. Divide by 2 to get the x by itself, and you'll find that x is 3. Now this makes sense because, look, your hypotenuse should be twice as big as the 3, as the smallest side, and it is. And if you look down here, 2 is twice as big as 1. So the 3 does make sense to be there. Let's go ahead and find that y value. Now, if we want to find the y value, the side across from your 60 is always the smallest side times the square root of 3. So if this is a 3, that means that this must be 3 square root 3. Let's take a look now at the other side, what we need to find the value of x. So if you take a look at this blue triangle, we have a 40-degree angle. We don't really need to find this part because we do have this value right here. So this would be your opposite side to the 40-degree angle. And then since the x is across from your right angle, the x would be considered your hypotenuse. So if we have the opposite side and we want to find the hypotenuse, we would want to use sine because sine is the opposite over the hypotenuse. So let's go ahead and use that trig function. Sine of your angle measure is equal to your opposite over your hypotenuse, which we don't know. Now this is a little bit different than what we've seen before because now x is in the bottom instead of the top, but that's okay, we can still do this. What we need to do is we need to get x out of the denominator. So when you have this equation, you really just want to multiply by whatever's in the bottom. In this case, it's x. So I'm going to go ahead and multiply x on both sides. X divided by x is 1. So on the right, we're left with 3 square root 3. And then on the left, we're left with x times sine of 40. Now we do want to get the x by itself, so the opposite of multiplying sine 40 would be to divide sine 40. So we're going to go ahead and divide sine 40, and whatever you do to one side, you've got to do to the other side. So now we divide and get x by itself, and then in your calculator, you're going to want to do 3 square root 3 divided by sine 40. Now it's really important that you do this multiplication before you do the division. Just be careful when you're typing that in your calculator, and I would actually practice it here before you try it on your test. So let's go ahead and try to plug that in. 3 square root 3 divided by sine 40. So 3, and then the square root button, 3. Now what we might want to do is just use the arrow button under the functions to scoot the cursor so that the cursor is outside of that radical. And now we want to divide by sine 40. Yep. So make sure you're in the gray. Sine, and then the 40 degrees. And then it looks just like how it looked like on our paper. So now we'll see that our value is 8.08, which would round to 8.1. Let's go ahead and use the 8.1. So x is 8.1. What is the value of x in the diagram? Okay, so it was looking for the value of x, and we found the value of x. I always like to read the question when I'm done, or when I think I'm done, to make sure that I'm answering the right question. So now we can go ahead and we can move on